All right, welcome to the Explainer. You ever look up and see a plane just gracefully carving a path through the sky and think, how in the world are they doing that? I mean, how do you steer this massive metal tube in the middle of a giant empty sky? There's nothing to push against. Well, let's get right into it. It's a really interesting problem when you stop and think about it, right? Up there are no roads to follow. There's no friction from tires on pavement, no guardrails. It's just space. Pure freedom, sure, but that's also a massive challenge for control. So what's the secret sauce?
Well, it turns out the answer isn't just one single thing. It's actually about mastering three really fundamental movements. And once you get these three down, you're basically speaking the language of flight.
And to speak that language, you've got to know its three core words: pitch, roll, and yaw. These are the only three ways a plane can rotate in the air. And get this, every single maneuver, I mean every single one, from a lazy, gentle turn to a crazy, steep climb, is just a combination of these three.
Let's break it down. It's actually super simple. Think of it like this. Pitch is just the nose going up or down, kind of like you're nodding yes. Roll, that's the wings tilting left or right, banking into a turn. And yaw is the nose swinging side to side, exactly like you're shaking your head no. Now, each of these movements happens around an invisible line, an axis, that runs right through the plane's center.
Okay, now this slide right here, this is the key to the whole thing. For real. You can think of this as the pilot's Rosetta Stone. It's where it all clicks together. It connects each movement, that's roll, pitch, and yaw, to its axis. And this is the important part, to the specific control surface on the plane that makes it happen. So, let's go meet those control surfaces.
All right, so these are the pilot's primary tools, the big three. We're talking about the ailerons, the elevator, and the rudder. And each one of them has a very, very specific job to do.
First up, we've got the ailerons. Their whole reason for existing? To make the airplane roll. That's it, tilting the wings left or right.
So how does that work? Well, the ailerons are these little hinged panels way out on the trailing edge of the wings. And here's the clever part. They always move in opposite directions. So when one goes up, the other one goes down. The aileron that goes down actually increases the lift on that wing, pushing it up. Meanwhile, the up aileron on the other wing does the opposite. It kills some lift. It's this perfect little imbalance of forces that makes the whole plane just roll.
Next up in our toolkit is the elevator. And yeah, its name pretty much gives it away. Its job is to control the pitch. That's the up and down movement of the plane's nose.
So when the pilot pulls back on the control stick, the elevator, that's the horizontal panel back on the tail, it tilts up. The air flowing over it creates a downward force, literally pushing the tail down. And because the whole airplane is pivoting around its center of gravity, like a seesaw, pushing the tail down makes the nose go up. It's a beautiful, simple lever system.
And that brings us to our third primary control, the rudder. Its job is to handle yaw, which is just swinging the nose of the plane left or right.
Honestly, the easiest way to think about this is like the rudder on a boat. It works exactly the same way. The pilot pushes the left rudder pedal with their feet, and that physical rudder on the big vertical tail fin swings out to the left. The air pushes against that surface, which shoves the tail to the right, and that, in turn, points the nose to the left. Simple as that.
Okay, so it sounds pretty simple, right? You want to turn, you use the ailerons to roll into a bank, maybe use the elevator a bit to hold your altitude, and you're turning. But this is aviation, and in aviation, there's almost always a little plot twist.
See, here's the thing. A good, clean, comfortable turn isn't about using just one control. It's more like a dance between all three of them. A pilot has to coordinate the ailerons, the rudder, and the elevator just perfectly. But why? Why all the extra work?
Well, this is the big twist I was talking about. Imagine you want to turn right. You use the ailerons to roll the plane to the right, but for a split second, the nose of the aircraft actually swings the wrong way. It swings to the left. So, what on earth is going on here?
This weird little phenomenon has a name, and figuring out how to fix it is one of the coolest little stories in engineering. It's all about solving a problem called adverse yaw.
Okay, so here's the culprit. Remember how we said the aileron that goes down creates more lift to raise the wing? Well, lift has a pesky sidekick called drag. It's an unavoidable side effect. So the wing that's rising up is also creating more drag, which actually slows that wing down a little bit. And if one wing slows down, the nose gets pulled in that direction, opposite of where you want to turn.
That is adverse yaw.
So engineers had to get creative to fix this. They came up with some brilliant solutions. One is called differential ailerons. The idea is simple. Just make the up aileron travel a little bit farther than the down one. This creates some extra drag on that side to balance things out. Another genius idea is the freeze-type aileron. This one uses a specially designed offset hinge. So when the aileron goes up, its front edge actually dips down into the airflow, creating its own drag. Two totally different, super clever mechanical solutions to the exact same problem.
Okay, so we've covered the big three controls for maneuvering. But pilots have a few other tricks up their sleeves to make flying more efficient and, frankly, a lot less tiring. Let's take a quick look at the secondary systems that help them fine-tune the flight.
I'm sure you've seen these. If you've ever sat in a window seat, you've definitely seen flaps extending from the back edge of the wings, especially during takeoff and landing. Their whole purpose is to change the shape of the wing to create a ton more lift and more drag. Why? It lets the plane fly safely at much slower speeds, which is, absolutely essential for getting in and out of an airport without a problem.
So imagine you're on a long road trip, and you have to constantly fight the steering wheel to keep the car straight. It would be exhausting, right? Well, that's where trim systems come in. You can basically think of trim as the airplane's cruise control. They're these tiny little adjustable tabs on the main control surfaces that essentially hold them in place. This relieves all that constant pressure so the pilot doesn't have to sit there fighting the controls for hours on end.
Now, the story of how these controls work doesn't end there, because the way pilots actually interact with them has gone through this huge transformation over the last 100 years or so. We've gone from basic physical connections all the way to incredibly intelligent digital systems.
Way back in the beginning, it was all mechanical. I mean, literally just cables, rods, and pulleys connecting the stick to the surfaces, kind of like the brakes on a bicycle. But as planes got bigger and faster, pilots needed more muscle, so we brought in hydraulic systems to help. But the real game changer was fly-by-wire. This is where we got rid of the physical connections altogether and replaced them with electrical signals and computers. The pilot's input goes to a computer, and the computer decides how to move the surfaces. And the future? We're already heading towards truly intelligent flight control systems that can learn, adapt, and maybe even help a pilot safely land a plane that's been seriously damaged.
And all this incredible evolution brings us to a really fascinating question to wrap up with. As these systems get more and more intelligent, going from simple cables to adaptive neural networks, the very nature of what it means to fly a plane is changing. So, as the machine gets smarter, what happens to the pilot? What does the role of the human in the cockpit even look like in the future? That's something to think about.